we're going to keep talking about our basic form. Now, I'm not necessarily going to do a lot with the calculator today. Again, like I have before, I'll show you what's going on. And today we've even got in here, if I can move, there we go. If I ever want to go ahead and graph these, I can always hit y equals. And I can go ahead, type in my parabola. And again, my x button's up here. I can do x squared, and then I can hit graph if I want to look at the picture. And I can hit second graph if I want to look at the values. Now, we talked a little bit yesterday about if I wanted to find my center point, my vertex, I just want to find a point where all the values above it and all the values below it are the same, and they're symmetrical. They go out from there. So this is an easy way for me to get those base values. My parent graph is what we were calling it yesterday. Except we expanded it, we expanded it a little bit today. So I'll be honest. What did I do? I'm skipping numbers. I'm being all sorts of a silly man today. For our basic purposes, if you've got this part down, after we've done this for another day or two, you're in good shape. Because those are the values that we were using yesterday to go ahead and graph my basic parabola. So, but we'll go ahead, we'll plot them all. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 1, 2, 3, 4. 1, 1. And again, the big thing about this parabola is it's not a V shape. For a V shape, that would be an absolute value equation. I want to get some curve to this. It's not going to be a ton, but a little bit. And I can get that drawn in, and I'll be ready and ready to go. So based on this parent graph, or our basic parabola, I can find out a lot of information, actually. A lot of things that'll help me when this parabola starts to move around a little bit. So we talked a little bit yesterday about the vertex and how the vertex is the point where it changes direction, or the center point, because wherever the vertex is, if I were to cover up half the graph, it doesn't matter which half I cover, I'm just seeing the mirror image of the other side through that point. So in a basic parabola, my vertex is going to be at 0, 0. We also talked a little, even though we didn't get into it much, about where you're like, well, it opens up, okay? But the reason for that is the value in front of my x squared. Now, if I don't see a number in front of x squared, what number's there? Is it 0? 1. Okay. So if that's a 1, my a value is 1. It's positive. So if I have a positive value in front of x squared, it opens up. If I have a negative, it opens down. Just that bit of information could help me out. But here's our new step today that I think is kind of cool. What's the step pattern? In other words, what's kind of like the slope of sorts? So if I start at my vertex, I go over 1, and I go up 1. And then from that point, I go over 1, and I go up 1, 2, 3. And I go over 1, and I go up 1, 2, 3, 4, 5. And if I had another value on there, that pattern would continue. Yeah, I'd go over 1 and up 7 if the next point was there, and then up 9, and then up 11. And the cool thing about this is you can use that with any parabola, even if it's moved. Once you know the vertex, you can just go from that vertex and go over 1, up 1, over 1, up 3, and you'll get the rest of the parabola. It's kind of cool. So now we're going to start making some comparisons, though, with this one. So here's how we're going to do this. I'm going to flip over here. I think we got the same next one. I don't think I got these out of order at all. But I'm sure you guys will let me know if we do. Okay, so x squared plus 2. Now, I'm going to try and draw this without plugging it into the calculator. I want to try something here. I'm like, okay. So I know I always start at 0, 0 here. Now for my base graph, I go over 1 and up 1. And again, I'm just going to put the dots for this first one. Over 1 and up 3. Over 1, up 5. I get my base dots. And I do the same thing going to the left. I can go over 1 and up 1. Over 1 and up 3. And over 1 and up 5. Okay, just like that. I got my base parabola ready to go. But what changes this time is that I have a plus 2 at the end. And that plus 2, what do you think that's going to do to all my dots? Which direction do you think I'm going to be moving them? Close. Nope. Up. Right, there's no parentheses, so that's going to be my up or down. So it's going to be up 2. So I just take all these dots, I go, okay, up 2, up 2, up 2, up 2, 2, up 2, up 2. Connect my new dots together, and I've got the answer. Now, we're going to look at it on the calculator just so we can prove a point here, that we don't need the calculator to be able to get to the right answer, but that we know how to do this on our own. So we'll go back to the calculator. Okay, we'll go back to y equals, and I'm just going to take that x squared and I'm going to put a plus 2 on the end of it. So when I do that, and then I hit my graph, okay, I notice it moved up. That's good. Now let's see how I did with my values. And we'll fill them in just to see. Okay, my vertex is at 0, up 1, 2. Awesome. Notice we went up 2. My y value, which is my up and down, went up 2. Okay. And the rest of my values that I see, negative 1 and 1 are at 3. Is that true? Negative 1, 1, 2, 3. Yep. 1, 1, 2, 3. Yep. My 2's, negative 2 and positive 2 are at 6. Let's see. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. Bingo. And I'm feeling pretty good now that these are going to be right. 3, am I all the way up at 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Bingo. See, I didn't even need that. We're still opening up because my a value is still 1. But I don't need that other stuff if I just plot a point at 0, 0 and do the pattern. Okay? The pattern isn't going to change. It just doesn't. And that's why I do. We get so dependent on all the, the electronic things, no matter what it is, that sometimes we take something that'd be really simple and make it hard because, well, I don't know why. Okay. So the next one, same idea, except now I have a minus 3 at the end. So what direction do you think we're going to shift all our points this time? Down. Okay, table of values. Who needs them? Because I'm like, okay, over 1 and up 1, over 1 and up 1, over 1 and up 3, over 1 and up 3, over 1 and up 1, 2, 3, 4, 5, 1, 2, 3. We're going to take full advantage of this pattern. There's my base. Move them all down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And maybe if you don't have like a different color that you're working with like I do, maybe you use like little X's or something for your dots instead so you can tell which one's which. 1, 2, 3. 2, 3. 2, 3. Same graph, just moved it down 3. But again, what happened to my vertex? My vertex y value, when I moved down, went down with it. Huh, down 3, y value went to negative 3. On the last one, went up 2, y value went up to 2. Interesting. Still opening up, because the value in front of x squared is still positive. But just keep telling yourself, hey, this pattern's the same, and I know this. I mean, this isn't going to be anything that's terrible. I'll rock this quiz out. What's the effect of a number is added or subtracted to the equation of the basic parabola? Okay, it moves it up or down. But the bigger thing maybe here is my vertex's y value changes. I can start making all of these connections to things, and then when we start doing more interesting things with our parabolas, it makes it a little bit easier to do all of them. But again, keep it simple. The less time you have to spend punching buttons, the better off you're going to be on these. And that's why we're taking so much time and doing so many examples today, so you can see how each of the individual things is going to affect how this works. Now, we talked earlier about it was up and down before because we didn't see parentheses. Now I do. So when the parentheses come in, now we're playing with left and right. So the question here is, what does that minus 3 tell me? Which direction am I going to be moving here? Okay, right. Because remember, when it's in the parentheses, the number's a liar. Negative, you'd think it moved left, but it's not. It's right. So I'm going to take my values, and like I said, if you just want to do the first 5, that's okay. If you still want to do all of them, and you want to do the last one where you go over 1 and up 5, that's okay. And we're just going to move them all right 3. Now we haven't hit any yet where we get overlapping, but that'll happen here sometime. So I can get my graph. Now interesting, my vertex moved to where x equals 3. So notice this time we moved right or left, the x value changes because again we're moving on the x-axis. Now we're still opening up. We will get to down sometime. But did the pattern change at all? Not a bit. Not a bit. And this will be the last time I write this way, because I think you get the point here. The step pattern still over 1 up 1, over 1 up 3, over 1 up 5. It doesn't change. And so I'm hoping that you're starting to see how these different parts can affect our graph. One more for you. One more of this type, we'll say. All right, we got x plus 4 this time. I'm going to get my basics down here first. What do you think that plus 4 in the parentheses does for me? I'm with you. Left 4. So I'm going to take all my points. I'm going to move them left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. There's one that overlaps. Okay. Who needs a graph? Who needs the calculator's table? We can do all the work just as fast and get the right answer. Okay. My vertex moved left 4 to negative 4. So we notice a pattern developing here like we did on the other one. If I add or subtract the x in the brackets or the parentheses, it moves our graph left or right, and it changes the x in the vertex. Because again, on our basic graph, it's always at 0 for all these things. But now that we start doing these shifts, my x and my y values can start moving. And sometimes they can even move at the same time. Kind of a scary thought. but they can. So you're like, okay, outside the parentheses, up, down, changes y. Inside the parentheses, left, right, changes my x value. Now let's see what else we could have up our sleeves here. Ooh, there's numbers in front. Okay, we haven't played with this yet. Let me get my basics down here. Okay, I'm just going to do those first 5 this time. Now you're like, okay. Ooh, so now what do I do here? All right, let's do this. I'm going to split my y chart up here into old and new. My original, okay, is at 0, 0, and then these are each at 1, and these are each at 4. But I have a value in front of x squared this time, which basically means now whatever these values are, I have to multiply by this number. So I'm going to times every one of these. And again, I know some of you absolutely could do this in your head, but I want you to kind of get to take a peek at it here for a minute. So I got 8, 2, 0, 2, and 8. So my new coordinate points, okay, are these guys. So -2, I'm at 8. 1, 2, 3, 4, 5, 6, 7. And we're going to find another pattern here in a minute. -1, 2. 0 is still at 0. 1, 2. 1, 2. Oops. 1, 2. 1, 2, 3, 4, 5. Here's what I want you to notice. Let's see what our pattern is this time now that we had a number. I went over 1. I went up 1. Okay. Oops, I went over 1, I went up 2. I'll get this right. I went over 1, I went up 1, 2, 3, 4, 5, 6. You're like, hey, didn't it used to be up 1, up 3? Yes. But what did I do? I took my regular pattern and I times it by that number. 1 times 2 is 2. 3 times 2 is 6. If I'd have done my up 5, that'd have been up 10. That'd have been right off the screen. But I can still use the patterns. I don't have to do this, but I wanted you to see where it was coming from. Okay. My vertex is still at 0, 0, and it still opens up. It didn't move my vertex at all. So it just means my pattern gets multiplied by the number in front. So for instance, now this one's going to get a little trickier to do, because you're like, they cut off the top of my graph, the silly people. So okay, I can deal with this. I'll go back, I'll do the chart one more time. So I go, okay, my value in front's negative this time. So I'm going to times all of these by -3. Now if you don't want to write in all the -3s, if you just want to write in the answers, you could. So my new points this time, because if I wanted to do a base graph, I really could have, and that's what I should have done. I just could go over and down, but I still could go over and down 3, over and down 3 to get my initial points. So I did the exact same thing I did up above with the positives, except, well, I flipped it down. I did like a mirror image of it. But otherwise, I could do the pattern still. Sure. Because let's look and see how this worked. I'll plot them from here. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Barely fit. -1, 1, 2, 3. Here's my 0. 1, 2, 3. 12's going to line up here. So I say, hey, My pattern is over 1, 2, down 3. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. And just think about it again. For my base, I went down 1, down 3. What did I do? I multiplied by 3. Just like I have in front there, except it was coming down instead of going up. The pattern still isn't changing. My vertex still didn't change. So when I multiply my basic graph by a number in front, when I have an a value, okay, this time it opened down because my value in front was negative. So what effect does that have? Well, it stretches my graph out, because you notice it's getting kind of skinnier than it was before. But it has no change to my vertex at all. My vertex stayed at 0, 0. I didn't move left or right or up or down. Well, yeah. So none of those things changed. Just stretched my graph out a bit and made it look a little bit skinnier, actually. So, okay, you're like, okay, what have you got left? I got one thing left. What happens when we run a combo of things here? So, here's what I'm going to do. I'm going to go past, okay, this properties part. Notice there's nothing here to draw a graph. We're just going to kind of base ourselves off of what we were doing. So I want to do the easy stuff first. My vertex, remember, is HK. And you're like, now how's that HK thing work again? Basically, it's going to be the opposite of what I see in here, and then the value I see on the end. So I'll do the first one. My vertex would be a 2, 1. Opposite of what I see in the parentheses, and I keep whatever's outside. And that's true even if there's a number in front of my parentheses. It's always going to be switch it, keep it. So if that's the case, what's my vertex in this next one going to be? Okay, 4, because I'm always going to switch this. And then I keep whatever's on the outside. One more here. What about this next one?
7.
Okay. -7, because we switched the inside, -4. We talked about the direction of the opening. All depends on if it's positive or negative in the front. If it's positive, it goes up. If it's negative, it goes down. Because like this one was +1 in front. This one's -1. Okay. This one's up because it's positive. Up because it's positive. Okay, if I did the next one, it'd be down because it's negative. And so on and so on. And again, all we're looking for with these is what the patterns would be. And I'll leave this middle part alone because I want you to actually be able to look at a graph when you're doing that. But this vertex and this up-down opening, important. Absolutely important. You're like, are we almost there, Harty? Yeah, we're on the very back page here. We're going to look at parabola number 1, and then we're going to be done. Okay. Oh, we got all sorts of stuff going on. We got a number in front, we got parentheses, and we got this. Holy cow. Okay. Lots of things to ponder this time. We're going to take them very slowly. Okay. Let's get our initial points in, like we always do. Now, before I ever start doing any graphing, I should be able to tell what the vertex is. What's my vertex going to be? -1, -8. Opposite and keep it, okay? So that's something I can know as I go. The parabola opens up or down? It's based off of this number. If it's positive, what way does it normally open? Up. So my A value is positive, it's 2. And then what are my 2 shifts going to be? I'm with you on the down 8, left 1. Okay, now this gets a little more complex. And I'm doing this one mainly just to show you some different pieces. I won't put ones that are this crazy with what we're going to be doing. So here's my deal. What I'm going to do is I'm going to take each of these points. It's going to be strange, but stay with me. I'm going to go left 1, and I'm going to go down 8. 1, 2, 3, 6, 7, 8. And I'm just going to use a little X for these right now. Okay, so left 1, down 1, 2, 5, 6, 7, 8. Left 1, 2, 6, 7, 8. Left 1. Okay. If, and I want to do this because it's more like the ones we would do, if that were the expression we were doing, and we will do some like this, the graph that we just drew would be my parabola. I took the whole parabola, and every one of those points, I moved left 1 and down 8. And I would put my drawing through there, and notice where the vertex is at. Now, we did the vertex before we ever drew this. Left 1, down 1, 2, 3, 4, 5, 6, 7, 8. Matches up. So I can get that value before I ever do anything. And the other things we're going to save for a bit with zeros and y-intercepts and optimal values and all of this other fun stuff. But if you can do that, you're capable of doing this. So keep this in a handy place because that's good stuff to use later. What we're going to be working on, and we're going to do a couple of things to this. Let me make sure I get this right. Okay. This is homework check 11, number 2. Evens are going to be the assignment. Odds are going to be extra credit, like a full assignment's worth. You're like, in the blank provided, write the equation. What? Okay. Watch how easy this is going to be for us. Here's how this works. So I'm going to help you by giving you what the vertex is for all of these, so you know what you're working with. So for instance, because here sometimes it's hard to tell where the x and y axis is at. So I've got a vertex at -3, 0. -2, 4. That's 7, 2. And we'll get back to doing the equations in a minute. I don't get to get away with just doing the vertex here. 1, 1, 4. Not sure where my axis is at. There it is. -6, 1. -8, 4. Keep boosting a little bit here. -1, -7, -4, -3, and holy cow, that one is far away. 6, -7 down there. Here's how this is going to work. I'm going to plug those values into my regular vertex equation. So here's how this goes. Let me move this back down. I'm going to plug values in those two spots. So like for instance, I notice on the first one, it opens down, so I'm going to put a negative in there. X minus, this is my h value. What happens when you minus a negative? It's positive. And then whatever's in the end, I plug in there. That's my equation. If I were to do that on number 3, let's say, it's the same idea. It's opening up, so I don't put a negative. I only put the negative if it's opening down. X minus 7, because I use the x value as well. Notice the only time it changes sign if it's a negative, plus 2. I'm done. Okay? So I'm just plugging those numbers in. I'm not solving, I'm not graphing, I'm not shifting, I'm not doing anything like that. I'm just working on plugging those in to make myself the equation. Now I'm going to flip to this next sheet for a minute. I just want to make sure we're all on the same page on what we're doing. Here, I just want to know what the shifts are, or the shift if there's only one. So like if we take that normal graph here, well, what happened? Let's see. Looks like I moved right 1, 2, 3. Because remember, we always start at 0, 0. So if I have to move left, right, up, down, I'm just going to write down whatever that happens to be. And I'm doing the same thing all the way through number 6. Whatever the shift is, like in number 5, it's down 4 because it's not in the parentheses. That's all you're doing. Do not worry about 7 through 9. If you want to, you can, because, well, it's kind of goofy, but that's okay. And then when you get to the back, focus in on 10 through 18. Same thing, just tell me what the shifts are. Up, down, left, right, whatever they happen to be. I just want you really getting used to understanding how those shifts work. And that's basically what we're going to be doing. And I see need to help here on the other side of our vertex form on getting you guys the vertices. So let me get those on the back here. 1, 2, 3, 4, 5, 6, 7. And I'm surprised I didn't notice that earlier. 2. Ooh, that's another long one. 1, 2, 3, 4, 5, 7, 8. All right, 1, 2, 3, 4, 5, 6, 7, 8. Keep jotting these down. We're almost there. Oops. Okay. So, your job again Evens are the assignment. Get those equations, get those shifts down. Once you've got those down, we'll be spending some more time next week doing some graphing, and then we're going to have one more form that we're going to look at.